So this was the crystalline solid and this was the amorphous solid. Now let us compare the character of both crystalline solid as well as amorphous solid. Since crystalline solid have the fixed geometrical strength, fixed geometry, fixed bond length, fixed arrangement of the molecule, since everything is constant and everything is fixed, in that case its melting point will be constant. That means if they have to melt at 100 degrees Celsius, then each atom of the given solid or given crystalline solid will melt at 100 degrees Celsius. Suppose if the common salt melt at, for example, at 30 degrees Celsius, then each common salt particle will melt at 30 degree, not greater than 30, not less than 30 in ideal conditions. So in case of crystalline solid, they melt at fixed temperature. Okay, why? The reason is because they have definite geometrical pattern, definite arrangement of atom. That is why they also melt at a fixed temperature. Okay, now in case of amorphous solid, these solid have different arrangement of atom. Somewhere they are closely arranged, somewhere they are closely arranged, but somewhere they are not attached even to each other. So in that case, if we heat or if we melt this amorphous solid, they do not follow the same trend. That is, sometimes they can melt at 30 degrees, sometimes they will require more temperature, sometimes they will require 25 degrees Celsius. So they do not have a fixed temperature, even they melt at a range of temperature. Okay, that means 30 plus minus 5 degree plus minus 10 degree, but they have the amorphous solid have the range of temperature where it will melt, while in case of crystalline solid they will melt at fixed temperature because of definite arrangement. Constituent particle crystalline solid का रेगुलर होता है, डेफिनेट ज्योमेट्रिकल पैटर्न रहता है, जबकि अमॉर्फस सॉलिड का इरेगुलर होता है। शेप क्रिस्टलाइन सॉलिड का फिक्स होता है, जबकि अमॉर्फस सॉलिड का फिक्स नहीं होता है। वी हैव डिस्कस दिस टू in detail. Now in case of crystalline solid, if you cut this crystalline solid by a sharp knife, suppose if you cut iron, okay, so after cutting, suppose if you cut iron from a side, then new surface after cutting you will get two new different surface, and these new surface will be shining, एकदम नया नया आपको दिखेगा और एकदम स्मूथ सा होगा। ठीक है, सो जब कभी भी आप किसी भी क्रिस्टलाइन सॉलिड को कट करेंगे, सपोज इसको अगर हम यहाँ से कट करें, तो जो नया स्पेस या नया सरफेस अपने को मिलेगा वो कैसा होगा, स्मूथ होगा, प्लेन होगा। बट इफ यू ब्रेक द चॉक इन टू पार्ट, इफ यू ब्रेक द ब्रेक इन टू पार्ट, इफ योर ग्लास इज ब्रोकन, सो जो नया सरफेस होता है वो तेज होता है, शाइनी नहीं होता है, स्मूथ होता है, इरेगुलर होता है। ऐसे में क्या होगा कि ये वाला जो अमॉर्फस सॉलिड होगा वो कैसा होगा, अपना इरेगुलर होगा। ओके, सो अगर आप क्रिस्टलाइन सॉलिड को कट करते हैं तो नया सरफेस कैसा मिलेगा आपको, शाइनी। बट अगर आप अमॉर्फस सॉलिड को कट करते हैं तो नया सरफेस आपको कैसा मिलेगा, इरेगुलर। हीट ऑफ फ्यूजन मीन्स जो इनका एंथैल्पी ऑफ मेल्टिंग होगा वो डेफिनेट होगा, as we have already discussed in case of melting point. So when you melt, when you fuse the crystalline solid, so you will get a definite amount of heat and it is always greater than the amorphous solid. Why? Again, because of definite strength. So when you melt or when you break the crystalline bond, so you will get always definite heat of fusion, while in case of amorphous everything is indefinite. Now the most important point, anisotropic and isotropic. Okay, so before going to discuss anisotropy or isotropy meaning anything which have same throughout, same character. ओके, ऐसे किसी भी चीज को हम क्या बोलेंगे, आइसोट्रोपिक, जो थ्रू आउट सेम हो, कोई भी उसमें डिफरेंस नहीं आ रहा। सो ऐसी कोई भी चीज कैसी हो जाएगी, आइसोट्रोपिक, जो थ्रू आउट सेम हो, पूरे में एक जैसे, जैसे आपकी नोटबुक का पेज, तो ये कैसा है आपका आइसोट्रोपिक पेज है। वाइल इन केस ऑफ अनाइसोट्रोपिक का मतलब क्या है कि ये ऐसा नहीं करेंगे, इनमें क्या होगा, ये थ्रू आउट सेम नहीं होंगे। जैसे कि आप सैंड ले लीजिए, तो सारे सैंड के पार्टिकल एक जैसे नहीं होंगे। आइस, अगर आप फ्रीजर में आइस बनाते हो तो सारे क्यूब एक जैसे बने, दैट मीन्स कैसा हुआ, आइसोट्रोपिक। अगर सारे क्यूब एक जैसे नहीं बने तो ये कैसा हुआ, अनाइसोट्रोपिक। ओके, so what is the case of anisotropic in case of crystalline solid? In case of crystalline solid, if you measure the physical or chemical character, if you measure the physical character of the crystalline solid. Okay, in case of crystalline solid, if you measure the physical character means like refractive index, like melting point, like refractive index, light character, reflection of light, refraction of light. So suppose if you are measuring from this side, so your view will be like this. That means in your view, no atom is opposing your direction. Okay, you can view, you are viewing from this side to this side. So exactly, there is no atom on the way, so there will be no reflection of light, there will be no reflection of wave. So this side character is you can get clearly. But if you are measuring the second side from this, now if you are viewing from this side, so the wave passing through this side will get reflected by this atom, again this get reflected by this atom. So the character observed from this side, that is horizontally, will be different from the character which are observing you diagonally. Okay, so diagonally observed character will be different from horizontally observed character. Why? Because in case of horizontally observation, there is no atom on your way, while in case of diagonally measuring, the wave is reflected by the present atom. So in this case you will get refractive index a different value, in this case you will get refractive index of different value. Such type of the character is termed as anisotropic. That is why crystalline solid are anisotropic, because when you are measuring the physical character in a crystalline solid, you are getting different value at a different angle. Such type of the character is anisotropic. But in case of amorphous solid, if you are viewing some character from this side, you will get same number of atom. If you are viewing the character from this side, you will again get the same number of atom. If you are viewing from this side, you are again getting the same number of atoms. Same number of atom means in each angle you will get the same value of a character. So amorphous solid is providing you the same value, that is why they is termed as isotropic, while crystalline solid will provide you the different value, that is why anisotropic. Okay, so one liner definition: anisotropic in crystalline solid we get different physical character on a different angle, hence crystalline solid are anisotropic, while in amorphous solid we get same value at different angle, that is why they are isotropic. Okay, we get the same character at different angle, that is why they are isotropic.